basketball with a volume of 0.00747 meters cubed at sea level with 1 atmosphere and 20 degrees Celsius. The basketball is taken to a depth of 500 meters where the temperature of the water is 4 degrees Celsius colder. What is the size of the basketball assuming the pressure in the ball is the same as the water at this depth, which is the correct assumption? Find its radius as if it were a sphere. All right, so what's going to be my strategy? Well, we'll start with thinking about this. The basketball is sealed, so the number of moles in it at the surface is the same as the number of moles down at sea level. The gas constant will also not change, so R won't change because it's a gas constant. So that means that if I take the number of moles times R, that's going to be a constant, and that won't change between the surface and 500 meters down below. I'll need to find the pressure at some point, so I'll use P equals P naught plus rho GH to find the pressure from fluid dynamics. And then I'm going to use PV equals nRT to find my new volume. So let's set this up. Let's start with the ideal gas law, PV equals nRT, and I'm going to solve for everything that's not going to change between the surface and 500 meters. In this case, that'll be nR. So PV over T is equal to nR. This means that the product of the number of moles times R at the surface in the ball is the same as the number of moles times R at 500 meters in the ball. So because of our equation, we now know that PV over T for the surface is equal to PV over T at 500 meters. The problem I have with this is I don't know the pressure at 500 meters. Since it's down underwater, I can use Bernoulli's equation or my pressure at depth equation. The pressure at 500 meters is equal to the atmosphere plus rho GH. So 500 meters plus 100,000 pascals times 1,000 kilograms per cubic meter, 9.8 times 500. That's going to give me 5 million pascals. So now I can put in all the variables that I have from the problem above, including my 5 million pascals, solve it for the volume at 5 meters, and what I get is an answer of 1.47 times 10 to the negative 4 meters.